Welcome to all in this lecture. In last week I was not able to upload any video due to some personal work, but now we are going to see the composite function part of the partial differentiation. Okay, so this composite function is based on the principle like if a is equal to b and if b is equal to c, then we can say that a is equal to c. In the same way, if u is a function of x comma y and x is equal to some r cos theta and y equal to some r sin theta, then we can say that x and y are the functions of r and theta. Okay, then we can say that u is the function of r comma theta. Why? Because u is the function of f x comma y, but x comma y are the functions of r theta, so u is the composite function of r comma theta. Okay, see here, if p is equal to f of x comma y, x is equal to psi of u comma v and y equal to phi of u comma v. Okay, that is p is the function of x comma y and x and y are the functions of u comma v. Okay, then we can say that p is a function of x comma y, xy is function of u comma v, then p is a composite function of u comma v. Okay, that is the main theory. So see here, if we say that f the function z is equal to f of a. Okay, z is only dependent on function a. Okay, so we can completely differentiate z with respect to a. Okay, we can completely differentiate z with respect to a as it is only dependent on a, but a is a function which is dependent on u comma v. Okay, and if we have to find delta z upon delta u, okay, then we will first see here z is dependent on a, so we will first differentiate z with respect to a. Okay, and then we will differentiate this a with respect to u, that is delta a into delta u. Why we wrote here dz upon dA? Because the z is the function which is only dependent on the single variable a, so it will be completely differentiated. But a is a function which is dependent on u and v, both the functions. There are two variables here, so here we wrote the partial differentiation of a with respect to u. Similarly, if we want delta z upon delta v, that is partial differentiation of z with respect to v, so we will write first we will differentiate this z with respect to the a. Okay, that is dz upon dA, and then we will differentiate this a with respect to e, that is delta a upon delta v. Okay, now take a screenshot of this slide. This is a formula which can help you in solving various examples. Okay, so let's move forward. If z is the function of x comma y, x is the function of u comma v, and y is the function of u comma v. Okay, then we can say that z is the function of x comma y, x comma y is the function of u comma v, that is z is a composite function of u comma v. Okay, we came to know this. Okay, so now let's find delta z upon delta u. Okay, now z is dependent on x comma y, so once we will differentiate the z with respect to x and we will add that term with the differentiation of z with respect to y. Okay, this is the first step, but we want to differentiate with respect to u, so we will again differentiate this delta x with respect to u, so this delta x upon delta u, and here is delta y, we want delta u, so we will again differentiate this delta y with respect to delta u. So finally we will get delta z upon delta u equal to delta z upon delta x into delta x upon delta u plus, as z is dependent on x comma y. So first we will differentiate with respect to x, and then we will differentiate with respect to y. Okay, so here we get delta z upon delta y into delta y upon delta u. Okay, that is how we will find a differentiation of a composite function z with respect to u comma v. Again, if we want to find the value of delta z upon delta v, then we can write delta z upon delta x into delta x upon delta v plus delta z upon delta y into delta y upon delta v. Okay, first we will differentiate with respect to x, that x with respect to y with respect to v. Then we will differentiate the z with respect to y, and we will again differentiate this y with respect to v. Okay, that is the procedure. Okay, take screenshot of this slide also, it is also important for you. Now this is the last type which we will include in our syllabus. It will, the questions will come on this type also. Okay, if z is the function dependent on three variables a, b, c, and abc is the function which is dependent on two variables, that is abc are the functions which are dependent on two variables r comma s, means if a is equal to some r into s square, b is the function is like s square r square, and c is the function like rs. Okay, so a, b, c are dependent on r comma s. This is just an example, but it can be anything. Okay, so z tends to a, b, c tends to r comma s, that is z is the composite function of r comma s. Then we will write the delta z upon delta r is equal to, first we will differentiate this z with respect to a into delta a upon delta r. Then we will differentiate this z with respect to b, that is delta z upon delta b, and again this delta b with respect to r, so delta b upon delta r, plus we will differentiate this z with respect to c, that is delta z upon delta c, again differentiating with respect to r, that is delta c upon delta r. Okay, similarly, we can write delta z upon delta s as first differentiating z with respect to a, and then with respect to s, again differentiating this z with respect to b, and then this b with respect to s, and again differentiating the z with respect to c, and this c with respect to s. Okay, so that is the formula for solving if z is the function of three variables and these three variables are dependent on other two variables. These are the two formulas which you will use to solve that type of questions. Okay, take the screenshot of this slide also. Okay, so thanks for watching this video. Also subscribe to our channel and click the bell icon for getting the latest notifications of our videos. Thank you for watching. In the next video we are going to see some examples on the composite functions. So have a good day.